There they are. I did that to you because we learned both. But we got to know how both work. Sorry, kiddo. Yeah. You ask when we get to it. We'll just hope that Frank's working today. Yeah, we're here on time, right? Okay. We got one of those. We got one of those. I see one of those. I see one of those. And those. So volleyball and tennis out. Who else is leaving today? Football's leaving. And cross country. All right. Yeah, unless we got a day where pretty much the entire junior class is out, like when we do smarter balance testing in the spring, we're usually just going to keep going because it's all online anyway. Yeah. Even though we can accurately show that people don't give a flying fornication about the smarter balance test and only try on the ACT, let's keep doing that because our state paid for an additional 5-year contract. Oh, I heard some of y'all yakking about something with English. Themes, I think. Is anyone doing themes in classes? I accidentally grabbed a stack of someone's papers off the copier and I don't know who it belongs to. No? Anyone? Themes in English? Alright. Everyone's got at least both of them written, so I can see if Frank works. Okay. Huh. Don't you hex it. Remember, open notes, open everything, just not your neighbors. Oh. Yo. Yeah, that's still the rule. That's exactly what we said yesterday. So domain is about who's not allowed to the party. Okay. Last time Maddie came over, she lit something on fire, so she's not allowed to the party. She breaks the rules. Okay. I have a vivid memory of Eric Anderson pouring gasoline in a ring around himself while singing, "We didn't start the fire, it was always burning." Like, y'all are young. You know who Beavis and Butthead are. Eric Anderson was the living incarnation of Beavis. Like, the kid was chaos. But, looks like we all good. Round one. What law of domain am I about to break? The first commandment of domain says, thou shalt not divide by 0. So, set the denominator equal to 0. And that is that. And you say, plus or minus 1 is going to make that a 0. Those are the things that aren't allowed. So, I state those as restrictions. Set builder, all x's such that x does not equal plus or minus 1, where x is an element of the reals. Okay, Lars, I think you had yours as an or. Doesn't equal this, or doesn't equal that. Cool. Okay. I suppose technically it would be an and, but yeah, whatever. We'll let it slide. Alternatively, I would say from negative infinity all the way until negative 1 is good, and then can't touch this. From negative 1 to 1, also cool, but then can't touch this. Okay, you say who's not allowed to the party. Contestant 2, same deal, except I'm about to break not only the divide by 0 rule, but I also can't have radicals or an even root of a negative. So set that equal to 0. 3 halves. If I put a 3 halves in there right now, I get square root of 0, which is legal, but dividing by 0, which is illegal. So that's the breaking point. Am I allowed to be greater than that or less than that? Greater, right? If I put in 2, we're good. If I put in a 1, bad. So we're going to have switch colors. I'm going to say either all x's such that x is greater than, not equal to, 3/2 x element to the reals. It's always element to the reals on these. Or I can say from 3/2 to infinity. And just leave it like that. So we're going to say 1 piece and 1 floating for the, I did the little doofus thing. Oops, I put a bracket here. Oops, I put an or equal to here. Oops, I wrote this part and this part, but I forgot that between -1 and 1 is also there. Okay? So 4 for the correct answers, correct forms, 1 for the oops, I did it again. God, I hated the 90s and early 2000s. So, any questions? Yes, ma'am.
For the first one, I did x is less than or equal to a -1. X can be greater than or equal to 1. For the set builder, can I do that?
If you had done a full compound where you also included the -1 to 1, like if you had said x is less than -1, or -1 is less than x is less than 1, or like if you actually said all 3, then yes. But you're still missing that middle part.
And then if I put that into the first one that you wrote there.
That's what I'm saying. Up here, if you had all x's such that x is less than -1, or -1 is less than x is less than 1, or x is greater than 1, such that x is an element of the reals. Like if you used inequalities for it instead of saying does not equal, you would need all 3. Okay. Which is why we say doesn't equal, because ew. Okay. Anything else? Okay. Then we'll just minimize that because I need to save it still. Ebook. Oh yeah, I could pull all your pictures up here on campus, and you see them all inverted. Looks like Blue Man Group. Contents. Frank. Oh, you're just being slow. Okay. Lesson. Wait, no, you did lesson 1 because we just started 2. Okay. Well, come on, Frank. You know, I asked all 3 of my other classes yesterday. They're all saying the same thing. Well, freshmen don't know, but that could be said about a lot of stuff. They were all agreeing that the laptops they noticed a significant drop in speed and processing ability this year. I think they are slower. You said 70 something? Okay. Come on, you. There you go. 76. Oh, we got to remember geometry. Represent the area of the circle as a function of its circumference. What's the area of a circle? Pi r squared. As a function of its circumference. What's circumference? pi times diameter, if I want to stay in the same stuff, I probably want to switch that to radius. So since the diameter is 2 radii, I'll say circumference is 2 pi r. Okay? So represent the area of the circle as a function of its circumference. That means I want to rewrite the area formula with c, the circumference, as the input. So I need to replace that r and somehow get a c in there. Could I rearrange the circumference formula in some way to say r is this stuff? Okay. So if I switch this to r is circumference over 2 pi r, or 2 pi, then I can replace this with this. The area is now pi times, not radius squared, circumference over 2 pi squared is pi times c squared over 2 squared pi squared is, cancel pi's, c squared over 4 pi. And then, since circumference is going to be my input, to write it in function notation, I'll just say a of c instead. C is my input. So we don't see it with circles very often, but it's very, very common in Algebra 2 and beyond to have an application where they say you rewrite using perimeter and area, or surface area and volume. You have to rewrite one to shove into the other so that you can write a function in a single variable. That's actually a really common application. But A, it's been at least a year since geometry. B, the general consensus I was hearing is that your geometry was the genuine quarantines for a lot of you. So I get it. Been a while, right? Once I have that, you cool with shove them in? And then what do you, okay, if you can't answer this one, what happens to the area as the circumference increases? Okay, right? As my shirt size increases, what happens to my body mass? God, the last 2 years sucked. So, 76. I think that was the only question that someone asked on Remind 2. Is there? 64? It is literally do it as it is said. If this is my function, find the function of a. Okay, put an a in there. Find the function of a plus h. Okay, put a plus h in there. Now that I know what those two are, take care of that expression up there. F of a plus h is the square root of a plus h minus f of a, which we said was square root of a, all over h. Ta-da. Now, some of these can be simplified, though. Like some of them, because these aren't the same radical, I can't combine them. I can't, like, say the a disappears or anything like that. So that just is the answer. But on some of these other ones, you might be able to take this minus this and things coalesce and you can cancel. What's up? 68. Okay. Same deal. Whoop, whoop. Well, except now I plug in an a into there. -1/4 a plus 6. I plug in a plus h into there. So negative 1/4 a minus 1/4 h, because I'm distributing the 1/4 to a plus h, plus 6. So the final answer, here we go, is f of a plus h, negative 1/4 a minus 1/4 h plus 6 minus f of a. All over h. Well, if I subtract, I really add the opposite. Negative 1/4 a with 1/4 a cancels. 6 minus 6 cancels. H over h cancels. Plug in a and a plus h. Get those two answers. Shove those two answers right here and here. And then algebra. Okay. I mean, you all know how math textbooks work. The first half of the assignment is always just practice with the mechanics. The second half is the, okay, now that you know how to do the thing, can you take it a step further? You know how to input things in functions. You know how to work with large or gross algebraic expressions. Can you do both? So, others? Okay. And we left off with, hey, stuff about graphs. And I think we finished this one off, right? Where we had the value of the stock on the 10th day was, oh, that's right, someone was real smug about it. It was exactly 32. And then where it's going to be $30 a share was on the 0th day. So like right after you start, at about 9 and 15 days. I'm sure there was a little bitty decimal on there, but on the 9th and 15th days is what most people had. So then we go forward. Use the graph to find domain and range. What's domain again? Okay. We're looking for exceptions to the domain, right? Who's not allowed to the party. So I'm going to state who is allowed to the party. For domain is input, x's. So when I got a graph like this, I'm just asking, does the thing exist? Does the graph exist? Okay. So let's grab this. That is the line x equals negative 10. Does the function exist? No. So you just keep going left to right across it, almost like the old pencil test, and just ask, does it exist? It starts existing at negative 8. Parenthesis or bracket. Bracket, because there's a closed dot there saying it starts here, it equals this. So my domain will start at negative 8, not infinity, 8. And when does it stop existing? Because there's a hole. A hole in the graph indicates this one specific spot does not exist. I'm not touching you, I'm not touching you, all the way up to that point. So we'll say negative 4, and we'll use a parenthesis to say can't touch us. And then continue from negative 4 on to when? Yes. On to yes, because that arrow says goes forever. So to infinity, parenthesis or bracket? Because we can't touch infinity. Okay. Yo.
Why did you start for domain at 8, negative 8, when like it goes down to negative 10?
Domain is x's. left to right, across the number line. You're looking right here and asking, does it exist? Does it exist? Does it exist? Does it exist? You look up and down to find where it exists, but the domain is the x's. That's actually where kids tend to goof up on this traditionally, is we look up and down instead of just yes or no, left to right. That's actually very common. So I'm going to do the same thing for my range and ask, when does it start existing? Watch the scale. That dot is right here, and they are going by twos, so -10. So my range is from -10. I'll use a bracket again because of that solid dot. And what about right here? They hit it twice. What does that mean? Does it exist? Yeah. So you just keep going. Remember, range, we don't care about it hitting multiple times. This function would not have an inverse, but it would exist on that part of the range. So I just keep going and going and going and going and going and going. What happens when I hit that hole? It exists because it might not be here, but it does exist here. I just care if it exists. I don't care where it exists. I don't care how many times it exists. I just care if it's there. So that means, when does it stop? To infinity and beyond. So all the way to infinity. That's just it. That's my range. So even though there was a hole on one part, because it existed at another part of the graph, there is no hole in the range. Okay? So you just use that vertical and horizontal line to go across the graph and ask yourself, does it exist or not? If there is no open circle to denote does not touch this number, assume it touches that number, which is going to be important for the range on 2a. Okay? Domain and range of both. I'd recommend interval notation because, again, that's the way the book does all theirs. So just get used to it. You got to know both, but that's the one we're primarily going to be using. Holy crap, that stream's lagging. I'm just erasing it and going to the next problem. Yeesh. I don't got that many kids missing. Talk to your neighbors. Argue. Who's right? Who's wrong? All we care, does it exist? Yes or no? Mm-hmm. What you have on your paper right there, what does that mean? No, I mean, what does this mean?
Goes from 6 to 6.
Did it move?
No.
An interval shows a range of spaces. How do I say there?
There.
Did you need to say from here to there?
You just say.
Yup. While what you wrote was not technically incorrect, it was overkill. It was the redundant department of redundancies.
So does this
Mr. Sir, yep.
not exist?
That particular point does not.
So it doesn't exist until like right here.
Uh-huh. No. Goes all the way up to that point without touching it. How do we show that using interval notation?
I don't know.
Listen to your neighbor.
I know, because how do you do this? I'll just use it. Yeah, exactly.
Okay. Hearing some good arguments. Domain is my x's, left to right. So I say it starts existing here. Parenthesis or bracket. Okay, it exists, it exists, it exists, it exists, it exists. It does not exist. Parenthesis or bracket. There you go. So the domain is going to be from -2 to 6, bracket parenthesis. The range. Question. There's both a closed and open circle. Does it exist?
Yes.
Yes. So parenthesis or bracket. Bracket. Because it exists. It is here on one of them, if not the other. And then, this is what I meant by, if there's not an open circle to specifically say it does not touch 4, we just have to assume it touches 4. Otherwise, we're going to be, just kind of guessing and winging it. Okay? So this one is from 0 to 4, double bracket. What's up, bud? Round 2, I'm going to do in front of you. Get up, take a lap, go get a drink. Caffeinate yourself, something.
Second. Every single
First semester, 2001, Mrs. Trozen's PreCalc? Algebra 3? No, Algebra 3 is what they called it. We had a kid who would fall asleep and she'd have every single kid in the room grab this monster book that was thicker than our PreCalc book and just, except we didn't on the floor, like on the tile floor next to him. Smack! I have done that once. We all just grabbed our stuff and we went outside instead. Yeah. So domain. When does it start existing? right after -4. So I use a parentheses to say -4. All the way up to, what do I do with this? If they're both open circles. Parenthesis, it does not exist there. There is two open circles. If this was an open and then a closed down here, okay, it would be continuous all the way through. Well, it's not continuous. That's Tuesday. So I have to put a break at 2. Parenthesis, can't touch that. And then to infinity. Don't get caught in the trap. There's a lot of kids who will see this heading down, and I'll see some kids try to put a negative infinity here. No, you're looking at the x's. The y's are headed down, yes, but the x's continue off to the right, to positive infinity on x-axis. Range might be a little bit trickier. When do they start existing? Negative infinity, because remember, you're coming up this way. So negative infinity, okay, up to right there, a -2, a parenthesis, does not exist. We know it's a union because it has a jump and then it exists somewhere else. Okay, there's a jump from here up to here. Does it exist or not? Because there's open circles, but there's a line. So it does exist. Think of a line as an infinite number of solid circles. Okay. So how do I write it? Okay. Now, if you do this, you're just plain wrong. Because you're using interval notation, but you don't have a lower and upper boundary. If you do this, the redundant department of redundancies. Because you're saying, all right, everyone want to watch me go? Want to see it again? I didn't move. You don't write an interval for just a location. It's overkill. Just 6. That's all you need. Just union 6. Nothing else. Okay, this is like turning x into 1x to the first over 1 to the 1th. Like, you can, but it's overkill. But it's not simplified. And we always simplify our stuff. So, after doing this, I always want to, okay, I'm just going to skip ahead to find an empty graph. Like, you don't have to write this part. Frank. Rat son of a... I'm just going to make one up. I want to see if we can do this. Okay. The gauntlet has been thrown. Get it? Come on, argue.
Okay, so the domain starts at infinity. Or no, wait.
Is it scaled by
By ones. Yep.
Negative infinity. I know. Never mind. How many things do you want us to write for this?
Enough to make the answer.
No matter what, where it's at, it's negative infinity to positive infinity.
Your metabolism can handle it.
What
Pick one and wake up.
What the crap? The domain is just negative infinity. I'm really tired.
You just slurred your words. It's gonna be like infinity or something.
I'm good. I got it. So it's negative infinity to infinity. Stretch. Alright, I'm ready. Wherever there's an open circle,
No. I usually reserve that just for my game club kids. Hmm? Pretty much.
and then the range is negative infinity. It's always
The range is not all real numbers.
where? Oh wait. Oh. So it's negative infinity to. Is it going by ones or is it?
Mhm.
Okay. 2, 3.
I hope the goof troop back there has their answers.
The range, yes. It's negative infinity to 3. Then would it be 10? With 4, right?
Okay, then write that.
Then, yeah, then 4 to infinity. Okay.
If it makes you feel better, I dropped my first F-bomb in class yesterday because I slurred my words. Yep. I was going to ask for a word problem if a kid's going to borrow $5 from me, and I just missed entire letters. So I asked if he wanted to borrow something else. I'm like, but I don't have any left to give. Okay. So most of us seem to have gotten it correct. When do, left to right, when do the x's start existing?
Negative infinity.
See that arrow? Off to infinity. So they start existing at negative infinity. And as I go left to right, I'm just going to follow this curve because, hey, I'm there. And when I get to that open circle, and there's an open circle, but here's a solid line, still exists. So I'll follow this line right here until I hit open circle. Well, I'll come down here, still exists. I'll follow that curve to the open circle, come down, still exists. All the way over to that line is just there to mess with you. That arrow says to infinity. So my domain is all real numbers. Or negative infinity to infinity, same thing. Okay. Now the range, do the same thing. Just ask yourself, does it exist? Okay, so from negative infinity, following it up, so I'm following this parabola on the right, all the way until I hit its vertex. But now I'll shift over to this cubic looking thing. And I'll move up and up and up, Frank, until, oh no, it actually moved the whole curve. Oh, you son. All right, and there was a gap of 1 in there. So there was overlap everywhere else, but there was a gap in there. So it would have been from negative infinity to whatever that was, union, the next integer to infinity.
Wouldn't
It was.
be a closed bracket though on the second one, but it touches.
They're both open circles.
Yeah, but it touches somewhere on the line.
But there's nothing here.
No, I meant on the second part.
Oh, okay, yeah, because there's a closed circle right there. Yep. Cool, cool. Just making sure that we can handle the bigger, uglier ones. Yes. Okay, so let's back up to we did those. There we go. Okay, y-intercepts. How do I find it algebraically? Plug in a 0 for x. A y-intercept is where it crosses the y-axis. Every coordinate on the y-axis is 0, comma, number. So plug in a 0 for x and you get it. These are all really easy to do. I don't think we need to go through the approximate it business because, put in a 0. 4/3. Right? Like, that's it. Put in a 0. Absolute value of negative 5 is 5. 5 minus 1 is 4. Okay, y-intercepts are nice and easy. Do the 2 below. No, y-intercepts are always easy. Oh, and please, 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 don't go to Decimal Town. You're a big kid. You learned about E and I last year. You simplified radicals in Algebra 1. You should have done it nonstop in Geometry and Algebra 2. So, that means we will write our answers in simplified fractions, simplified radicals, simplified terms of pi, I, and e. So, 0, 0, 0. Y-intercept is 4. 0, don't overthink it. What's the y-intercept? Square root of 6. And leave it like that. Don't you say 2 point blah, 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 blah. Okay? But x-intercepts, the other way around. I'm going to put a 0 in for y, and now we're going to probably have to do some solving. So hopefully you remember Algebra 1 and 2. If I plug a 0 in for, okay, technically remember, I'm putting a 0 in for y. Since the y is equivalent to the feature of f of x, I can then replace, okay? Don't want to argue semantics. If I plug in a 0, solve. Well, I'm pretty sure that's factorable. I know it's 2x and x because 2 is a prime. So factors of a negative 15 that are going to make this work are plus 3 minus 5. Okay. So you can either get your mental mojo on. Hopefully you can do that by now. Otherwise, you're going to do the full 2x squared plus x minus 15 is 0. Negative 30, split this. 2x squared plus 6x minus 5x minus 15 cutting in half. They got a 2x in common, leaving x plus 3. They have a negative 5 in common, leaving x plus 3. Take out a x plus 3, get a 2x minus 5. You can do the full AC method if you have to. But with 2 being a prime, I'm betting most of us in here should be able to just mental one-shot it. Guys are... That's how I solve, right? I'm saying this thing equals 0. Well, I just said a times b equals 0. That means one of them got to be 0. So set this equal to 0. X is negative 3. And set this equal to 0, 5 halves. Those are your x-intercepts. Because remember, x-intercepts are where it crosses the line y equals 0. So x-intercepts are also called zeros, are also called solutions, are also called roots. Okay? They all have a different meaning, but they're all referring to the same feature. Okay? Yeah. So, let's see what you remember about Algebra 1 and 2. Solve. Set them equal to 0 and solve. I should put this in the fridge for later anyway. Does it bother anyone else when they leave the microwave blinking at like 3 seconds?
Drives me insane.
It bothers me, but I also do it all the time.
One time I got my microwave to say 0 and I thought I completed life.
You stopped it at 0 or like so you
Yeah.
cool.
It's like the perfect pump. I'll put $20 on 5. Chink. Exactly 20.
Oh, it's like so disappointing when you do it and it's just like 0.01 and you're just like.
Factor out an x, right? Greatest common factor. Again, 3x squared. 3 is prime. So I know it's going to be 3x and x. I just need to mental mojo some factors of 8. They're going to make this work for me, like negative 4 and positive 2. So x is 0, negative 2/3, and 4. Set each one equal to 0.
That is not what I got. I got 2 and then 4.
Yeah, I got 1
I got 0, 2. I don't.
Because that's negative 12 plus 2 is negative 10 in the middle. Yeah.
What?
No, it doesn't. Did I put a wrong sign up there? No, that's all right. Oh, that's a positive. Oh, man. That's a positive 8. That is a positive 8. So let's try that again. They both have to be negative. Narf. So minus 2 minus 4. Okay. That's positive 8, not negative 8. Where's my marker? It's close. Ah, crud, that's right. You had one earlier. Rack them up at the beginning. Because usually, like, no joke, the graph of brownie points usually looks like that over the semester. Just because we get into new material. So, yeah. The other one, y'all cool? Just negative 1/4. Square both sides. 0 squared is still 0. Subtract 1, divide by 4. Okay. Okie dokie. So, domain from a graph, or domain and range from a graph. We cool? How about x and y intercepts? Show me thumbs. I can do both. X and y intercepts. I'm good. A little fuzzy. I should probably do one more. Dude, what the hell is this? No? Okay, cool. Then, symmetry test. We got to start learning how to do proofs again. Now, there's different kinds of proofs. A, paragraph proofs suck. Did you ever have to do a paragraph proof? Where you literally write out the measure of angle this is congruent to the measure of angle this because of this theorem, period. Therefore, okay, paragraph proofs suck. Sorry to break it to you, if you go far enough in math, like past differential equations, that's pretty much what you're going to do. Okay, proofs, lots of proofs. Like that's the capstone course to be a math teacher is actually abstract algebra and ring theory, where you prove why math works. So, well, I'm a teacher. Oh, I didn't just do it. I did that independent study because I had already moved. They gave me the book and said, "Tell us when you're ready for the final." It sucked. That was the only time in my career I've ever hated math. But anyway, you had 2-column proofs, is what most kids remember. Please tell me your teachers used flow proofs. Oh, flow proofs are so nice. Okay, now I'm biased. I see the world in boxes and color coded and like pop outs like Iron Man. That's just how the world looks to me. Each one of you has got like kind of a status symbol flag next to you. That's just kind of how I see things. It's how my brain is wired. So when I have this and this leading to this, leading to this, with another axiom here to get to the final answer, and in there you'd say something like measure of angle A congruent to measure of angle B, and then you would say like I don't know, ulterior or alternate interior angles. So like you would say, here's the thing, here's the reason, here's the thing, here's the reason, but then you can show where that idea is going instead of having a 2-column list where you just got to kind of keep track of it. But you can physically see where that idea goes. Okay. Y'all missed out because this really helps a lot of kids visualize why am I even doing this. Okay. Think about it like 2-column proofs. Most kids hate it because it's like trying to put together the Lego model, but you accidentally missed a page. Smooth. Okay. You ever done that? Like you flip the page, you're like, whoa, why is there a whole tower there now? Oh, wait. Okay, I just missed a page. That's why kids seem to hate 2-column proofs, is because you're taking something from 3 lines up here and using that idea down here. In a flow proof, you literally have a box pointing this to that, showing you that's why it happens. There's also algebraic proof. Algebraic proof is where I show you with all variables, not numbers, variables, that this is true for every case. Because I have a variable, not a number. Variable can change. If I show that it's true no matter what, because it's just an x and a y, then it must be true no matter what number I put in there. That's algebraic proof. You should have done that at the back half of geometry, especially when you're doing a lot of formulas. Yes, no? Yeah, okay. Sad. I so sad. You know what symmetry is, though, right? The butterfly thing. You can fold one onto the other. Okay. The three types of symmetry that we're going to work with are symmetric to the x, y, and origin. X-axis. Well, I can flip it top to bottom, still the same. Y-axis, I can flip it left to right, still the same. Origin is x and then y, or y then x. 180 degrees. Okay? Take that cubic. I should be able to take my paper and whip it 180 degrees, and it's the same thing. Y'all got a paper in front of you, right? Grab it. Still the same picture, right? That's how you know if it's symmetric to the origin. Now, what you got to be careful about is you can be symmetric to other points and other lines, but it's not these specifically. So I might have a, no, don't do that. I might have an absolute value graph way out here. It does have symmetry, right? Like it literally has an axis of symmetry. But that axis of symmetry is not the y-axis. So it's not one that we're going to test. Okay? Specifically, it has to be x and y-axis or origin. They all got rules. Frank. They all got rules that say, if I have a positive y, I also have the mirrored y. That means I can replace y with a negative y and the equation is going to look the same. Okay? I can replace x with negative x and the equation is going to look the same. I can replace both x and y with negative x and y and the equation will look the same. Okay? With each of them, we're going to do both, it's called algebraic proof and numerical support. So let's say this was, I can't do that one because it's not a function. No, I can. What if I said x plus 3? Y plus 3. Y plus 3. Been a long time. Say I put in a negative y. Well, if I factor out a negative y, sorry, negative 1, y minus 3, whatever that is. Oh no, you guys haven't done absolute value proofs with non-functional ones. Let's do parabolas. Everyone knows parabolas. There. Everyone knows parabolas. Okay. You haven't done absolute value if it's not a function yet. I should be able to replace x with a negative x. And lo and behold, it's still the same thing. That's algebraic proof. It's really simple. But I showed that if I negate my x, I end up with the same thing anyway. If they say numerically, well, first you'd have to find any point that is on the graph. So I'll just randomly throw in an x like 2. 2 squared is 4, negative 4 plus 3 is negative 1. Okay, I know that that point is on the graph. So to support this numerically, I will negate my x. And I should still end up at negative 1. Okay, so y is negative Negative 2 squared plus 3. Well, that's still 4, that's still a negative 4, that's still plus 3, it's still negative 1. Even though I negated my x, I still ended up with the same y. Algebraic proof, numerical support. That's what the symmetry test is. Now, the book wants you to do all 3 tests for everything. I'm going to say, if it looks like it's symmetric to x, only do the x one. If it looks like it's symmetric to y, only do y. If it looks like it's symmetric to origin, only do origin. If it looks like it's symmetric to all 3, okay, do all 3. If it looks like it's symmetric to none of them, all right, you got to do all 3 to prove that it's none of them. Okay. So, symmetry test is replacing x's and y's with negatives. Use the graph of each equation for this test for symmetry. Do the things, confirm algebraically. So we start with the this. Y'all even know how to graph it?
I'm not gonna say anything.
Start by getting y by itself. Y'all know how to algebra. Subtract x over, divide by -1, square root. Or I could swap those two. Say y squared is x minus 1. Square root. Square root. Because I put the square root in there, plus or minus the square root of x minus 1. Y'all remember how to graph radicals? Okay. A principal root of just square root of x would only have the top part of the curve. It's a sideways parabola. You still use your perfect square steps, it's just they're all on their side. Because instead of input number square it, now it's input number square root it. So I'm still going to have a transformation of right 1. And then from there, I'll use perfect square steps on their side. Up 1, right 1. Up 2, right 4. Up 3, right 9. It's still the perfect square steps that we would use on a parabola. It's just they're sideways. But this is plus or minus. So there's my positive version. Here's my negative version. Okay. So I've got the graph. What does it look symmetric to? Looks symmetric to the x. So I will run the x symmetry test. Go back and look at that little chart. What do I do to prove it's symmetric to the x-axis? Negate the y. So I should be able to take my original equation and negate the y, and it should still come out the same. Well, what happens when I square a negative y? It's still y squared. So, yay! There's my proof. It doesn't have to be tough, but I did have to show it. Okay? Y'all remember back to the beginning of geometry when you were doing like line proofs? Prove that angle A is congruent to angle F. And you're like, well, friggin' look at it. I could trace it and put it right on top of there. Like, duh. But then you still had to do like a 5-step proof. Okay? Yeah, I know that this is symmetric. Look at it. But I have to prove it. Okay? Now, it asks for algebraic proof, but it also asks for numeric support. So I got to pick a point that is on this graph. Please do not pick anything with zeros. Why would I not want to pick things with zeros as I'm testing symmetry? Because when I negate 0, it's still just 0. Like, you can't prove symmetry if it's on the line of symmetry. That's like your face is on the mirror. Like, it's the same thing. So I'll pick a point like this. That's what, 1, 2, 3, 4, 5, 2. So if I know that 5, 2 is in the original, and I'll prove it, 5 minus 2 squared is 1. Sure enough, 5 minus 4, 1 equals 1. I should be able to negate that y and say 5 minus negative 2 squared is 1. Well, yeah, duh. But I still had to show it. Okay? Well, I have to show that the original works and then the negation works. Show that 5, 2 is on it. Oh, you do both. Because this is the algebraic proof. This is the numeric support. Where it sucks is when you have to do all three. Because you'll have to do that for x, you'll have to do that for y, you'll have to do that for origin. Okay? I try not to include those, but you might see it. Okay? Again. Oh, how do I graph this? I haven't seen it since Algebra 1. It's been 3 years. Okay, divide by x, get y by itself. How do I graph it? How do I graph anything I have no friggin' idea how to graph? Get that table. We went through how to graph by table. Prove it. I know what it looks like. You show me. No, it is definitely not a line. I remember you. Now graph it with actual points. Mm-mm. What's right above graph on your calculator? It's almost like we went through that in class.
Mine says error.
Bruh. Come on, get that graph on there.
No, like, because there's a point where there's nothing, so this is error.
Mm-hmm.
I thought you were like looking at me like when I entered it.
Oh.
Oh.
And especially when you see that table, I want to see if you recognize the pattern to it, how I could graph this without using that calculator. I swear, you stop that. Wait till you have kids. There's a reason young people are supposed to have kids. Don't have kids in your mid-30s. It hurts. No, that wasn't. Don't pity me. That wasn't even close. Okay. Yo, what's 4 divided by 0? Doesn't exist. So it's a gap in the domain. Specifically, that would be a vertical asymptote. Gap in the domain. What's 4 divided by 1? 4 divided by 2. 4 divided by 4. And the more that I chop it up, will it ever hit 0? What's 4 divided by 1,000,000,000? Are we at a 0 yet? No. Okay. That's like if we took Holden, we tossed him up in the air, and we just started going Fruit Ninja on him.
The chicken nugget machine.
The chicken nugget machine. Okay. Is there eventually 0 Holden?
No.
No, there's Holden soup. But each piece is still worth something. so, so what is 4 divided by -1? Divided by -2. Divided by -4. Okay. Which means I also have a horizontal asymptote at y equals 0. Now, the way to prove that 0 is the horizontal asymptote, try to put 0 in for y.
I did.
If I put 0 here, cross multiply, I get 4 equals 0. That's not true. Okay? So you can show that a horizontal asymptote exists. Now, does it look like it's symmetric to the x, y, or origin? Okay, so to prove that it's symmetric to the origin, I'll say xy equals 4. What do I negate? Both. So I'll show -x times -y. Does that equal 4? Sure enough, it does. For numerical proof, I want to find a coordinate that exists on this graph. Okay, I heard 1, 4. So show that 1, 4 exists on the graph. Show its negation works. I know it's tedious. Okay, I know it's tedious, but your algebraic and your numeric proof and support, respectively, they shouldn't be difficult. Now, you can use ugly numbers too. You can use nasty numbers and show that this still works. Could I put in if x, y equals 4, could I put in a 3 squared to 2? Yeah, I can. Why would I do that? Because I'm a masochist? I don't know. I'd put in square root of 2 over 3, right? Square root of 2 times square root of 2 is, oh wait, no. 2 square root of 2 over 3. There we go. Words. Hard. Math. Sometimes harder. Square root of 2 and square root of 2 is 2. 2 by 2 is 4. 3 over 3 cancels. So it does work. Can I now show that if I negate that, it still works? Right? So if you have to use ugly numbers because you don't know a nice coordinate that fits on the graph, just work with the ugly numbers. Y'all in PreCalc, you've seen them before. You know how they work. You may not like them, but you can work with them. I have to do that with multiple. You can do this. Okay? So, which one? You said the circle makes you happy?
No, I meant like as
5B is all
not as
3
in
of them,
problem.
isn't it? 5B, all 3 of them.
It is all 3 of them. And I don't want you to do all 3 of them. That's just mean. So we're going to split it up. Right down the middle here. Buzz cut. I want all of you to do the X test. I want all of you to do the Y test. I want all of you on the side tables to do the origin test. Go. You're doing X. X, Y, origin. Okay? So everyone's doing a piece.
Actually, I'm gonna get exactly the scale. Y squared.
Now, if you can find a nice set of coordinates that does not involve 0, you can't use 0. Using 0 is cheating. Okay. If you can find a nice set of coordinates, go for it. If you can't, well, just pick a number and toss it in there. Throw in 2. Get a radical. Work with it. Okay? So one group's testing X symmetry, one group's testing Y symmetry, one group's testing origin symmetry.
I'm trying not to laugh.
And that's why I still haven't graded the last of the quizzes from last week. Because I get like that around 8:30, 9 o'clock, and I look at my pile and go like, nah.
I was up until 1 in the morning doing EMT.
I can't do that anymore. I'm too old.
I had everything else done, but my EMT homework took 3 hours.
Yeah. No. Our our second child burned that ability out of me. Child number 2 didn't let us sleep for 7 months. Our record was 5.5 hours. 7 months straight. I kept a sleep log just to prove, because I'm going to put it in his face later when he's a teenager, and I'm waking him up at 2 in the morning because I feel like it.
Hey.
Sucks to suck. No. A baby stays, keeps you awake for like the first couple weeks, months, and then starts figuring out life. No, I'm talking about we averaged 3.5 total intermittent hours between 9 p.m. and 7 a.m. for 7 straight months. 3.5 hours per night for 7 months.
Rather than like mom and baby.
And all like parents do is like 100 hours. Probably more than that.
You lose lifespan. Yes. But anyway, I love him. Like, he's my boy, he's my little tater, but whew. Goblin 1 and Goblin 2. Hey, y'all, do you remember such a thing as Pythagorean triples?
No.
3, 4, 5. 3 squared is 9, 4 squared is 16, 9 plus 16 is 5 squared, 25. Who found 3, 4, 5? Okay. So, if you didn't, you just had to work with an ugly radical. What number did any of you try? Do you just say F it and throw in a 1 for X and go for it? Okay, let's do it. So, to show X symmetry, what am I negating? The Y. So, my algebraic proof is if I have X squared plus Y squared equals 25, I should be able to do X squared plus negative Y squared equal to 25. And sure enough, yay, it works, because that's how squareds work. If I want a coordinate that works, well, if I put a 1 in there, what does the Y have to be? The square root of 24, right? Now, I can simplify that down to 2 square root of 6. But for the purposes of our proof, since we know we're just going to square it anyway, could I just leave it as square root of 24 to show the work? Yeah. So I showed that work. Maybe I'm going to say 1 squared plus negative square root of 24 squared is 25. And sure enough, 25 is 25. You don't have to overkill this thing. Okay? Did anyone use something different for the y symmetry?
We went the long way and changed the
Oh.
Yeah, we did that too. That's why we started to. We overthought that.
Oh, yeah, that's overkill. Don't do that. Don't do that. You all use a different coordinate? You said you found 3, 4, 5. Okay. So, again, x squared plus y squared is 25. I should be able to say now that negative x squared plus y squared is also 25. And sure enough, yay. If I have the coordinate 3, 4, or 4, 3, then I should be able to say 3 squared plus 4 squared is 25. I can now say negative 3 squared plus 4 squared is 25. 25, sure enough, is 25. Okay? They're not always going to work out like that. You won't always find a nice number. Okay? Anyone else have a different coordinate over here?
Well, we are totally lost. So
All right.
I think
Okay, I heard 2 and squared and 21. I'm going to roll with it. We have x squared plus y squared is 25. So what am I negating to show origin? Both. Negative x squared plus negative y squared is 25. When I square a negative, sure enough, it's positive. X squared plus y squared is 25. Yay, it checks out. You said you used 2 and square root of 21? Well, it works. So why not? You don't actually have to think. I mean, it's square root of 21. I squared is 21. Okay? So if I can now negate negative 2 and negative square root of 21, sure enough, 25 is 25. Okay, so there's the proof. I have done algebraic proof and numeric support. Don't quit on me yet because we got one more example.
My brain quit like an hour ago.
Even in odd functions. Even in odd functions, read what it says. Functions that are symmetric to the y are even functions. Functions that are symmetric to the origin are odd functions. So all of this is same as the thing right before it. Okay. Now, it does say, graph the function, tell me which it is, confirm algebraically. You just do exactly what we just did. Okay? The difference is now you're going to say instead of symmetric to the x, y, origin, or nothing, you're also going to say even, odd, or neither. Okay? So we don't need to do the extra examples. It's the same thing. Okay? All right. That's that. Remember, when you come on Monday, it'll be a review and quiz. And then 4 days. Oh, damn. Okay. Next week's homecoming, isn't it?
No,
I thought it was early.
No, it's the 24th.
Oh, it's the week after. Okay. All right. Normally it's in October, so it kind of sprung up on me like that.
Do we even have a homecoming dance, or is that just not a thing? Do we not do a homecoming dance anymore?